So thanks for the introduction and thanks for the opportunity to present the work that we are doing within the project. So I work on preclinical imaging, essentially. Yes. Right? No? Okay, so that way. So preclinical imaging is quite a smaller imaging community when compared to biological or to the clinical one. Of course, we are acquiring images in living animals, and in order to detect, monitor disease progression, and evaluate the response to treatment. And within the images, or thanks to the images, we can obtain information not only at organ and tissue level, but also down to the cell and the molecular level. Also, with the aim to improving the efficiency of the drug development process, and within preclinical imaging, you can also match the free R principle, so in order to reduce the number of animals that you need. It's quite a multi-domain complex, or multi-domain, or it's very complex in terms of the different levels, in terms of imaging modality and instrumentations, since you have different imaging techniques and even different imaging subtechniques. You obtain quite a large variety of different types of images, both considering the raw images or considering the parametric images, and so different file formats, also problems that we've already seen before. You have several processing tools, and most of them not easily, do not, let's say, communicate very easily. You have a variety also in terms of study protocols, in terms of in which way you can annotate the images, in which way you can actually reuse the images that you have obtained. And then you have, of course, the users that have different expertise and that also they should somehow adhere to the FAIR principle. So this is the complexity of the preclinical imaging community, and at the same time, we also have a paucity in terms of repositories. Since if you try to look for a preclinical image dataset, it's very hard. Usually you have a few initiatives, usually at a local or single institution level. Even if you find repositories, they may lack of metadata information or they are not curated at all. Some of the repositories are limited to specific domain, and some others may have small datasets or without any information about the way in which you can reuse the data. And here I just provided some example of more specific repositories or other like open and generic ones like Zinode or Figshare and so on. So there are other type of repositories that allow you to put your data, but from which it's very hard to find them or to have enough metadata information. So the question that we may have is how we can improve these in order to make more findable the data that we are producing. So the one answer should be as easy as this one, as you can find here at the Brisbane Museum. That is, we have to share. This is by Richard, and even more interesting is the commentary to this artwork, where the emphasis is not only to share, but also is on having. So if you have, you should share it. And this is also true for our community. We have a lot of data, and we should share them. Another answer is also thanks to the foundingGIDE project that aim to involve more people across different continents in order to develop this kind of standards, in order to have a further discussion and recommendation. In particular, I will talk about what we have done on the preclinical image data. Essentially, there are two key ingredients. You want to develop FAIR data. On one side, you have the harmonized and structured metadata model. So you need to describe any type of information, so any type of metadata that is useful in order to describe the images that you have collected. And on the other hand, you have the ontologies that are needed in order to create the metadata and in order to make them also more interoperable, potentially across repositories. So we started by developing, let's say, a kind of metadata model for preclinical image dataset. Hopefully we didn't have to start from scratch or to reinvent the wheel, so we exploited the RAMBI model since this was proposed for the biological imaging community, and also by exploiting this, this should also simplify the process of interoperability across the different imaging communities. And then it was, let's say, integrated with some ready recommendation coming from the ARRIVE principles on guidelines that are also some journals and publishers requesting. and the prepare guidelines that are more specific to the preclinical community, and then look also to some white paper like related to the standardization description of the imaging methods in preclinical imaging. So we take advantage of this white paper recommendation, and then we created this kind of metadata model that is composed of 8 main sections in a similar way as the RIMB model that describe different information at the study level, at the level of the in vivo experimental parameters and procedure that in this way are more specific to the preclinical image domain, and then a 3 more section related to image acquisition data, and 1 section for the analysis of the data. And this is the way in which we have built up the RIMB model, the preclinical model that looks like to the RIMB one. Just to remind you that each step you are collecting metadata, each step you are producing metadata, so meaning that you should take care of all of this information that then should be associated to the images. Another complexity, of course, is the preclinical imaging is a very multidisciplinary field, so this means that we really need to collect information coming from different domains. And then shortly we show you how we try to enrich the metadata with some curated, with some ontologies. And this is just to provide you an example where you can collect all the information starting from the study components, so information in the study, information, for example, about the target, about the number of mice, in which way they have been split between 2 cohorts, and all the experimental procedure, and then information related to the scanner, image acquisition, and the way in which you can analyze the data. And then essentially all of this section we collect all the information that are related to the image dataset, and all of this information will be listed or will essentially fill a list of metadata divided for the different sections. So this is the way in which we are. We have a model, this preclinical metadata model, and then we also exploiting some metadata in order to improve the reusability, meaning that we provide also information about the license by which you can have access to the data, and then exploiting the data use ontologies that allow you to have information about in which way you can reuse and which are the permissions for reusing the data. And this should improve the reusability of these images. And an important point is, of course, how we can reach a consensus. So the initial proposal of this metadata model started within the Euro-BioImaging nodes. Then, thanks to the foundingGIDE project, it has been further improved. Thanks to the feedback from the partner on the project. And then we would like to reach a consensus by involving several communities, starting from the European Society of Molecular Imaging Standardization Group, and then reaching also to the global bioimaging network, several imaging facilities, since we will really have feedback from all of these preclinical imaging centers in order to develop something that is meaningful for the whole preclinical imaging community. And then, of course, from anyone that might be interested to help in developing this kind of standard. And another point is related. Sorry. I need a mouse to move the slide. Okay. Another point is related to the ontologies. So ontologies are used in order to resolve the semantic ambiguity. So meaning, of course, that you need ontologies when you, for example, have image data set that are related to breast cancer, but you are performing a querying by using the term mammary cancers. So you need this kind of ontologies in order to resolve the ambiguity. Or if you are, let's say, performing a querying by, let's say, looking for, let's say, a drug, and then you can use the commercial name, or you can use the chemical name, or other way to name the same molecule. And so in that way, you need ontologies. So we performed also this kind of landscape analysis. So we first identified the different domains. And you can see here that there are really a variety of domains. So looking to disease, looking to cell line, pathology, phenotype, genomic anatomy, strain, chemicals, imaging, and so on. So as I told you before, it's a very multidisciplinary domain, and then per each domain we identify at least 2 to 4 different ontologies that can cover the different domains. And then we perform a kind of analysis of all the ontologies that have been identified by collecting several information, as you can see here, in order, let's say, to compare the information provided by each of the discovered ontologies. And then we perform this landscape analysis, essentially, and this matrix or scoring system that allow at least to select one ontology per each of the different domain. And this allows to produce this metadata schema where we will link some of the metadata to the different ontologies. Still work in progress, actually. And at the very end, what we would like to have is this repository. So we started working on this repository for preclinical image dataset. Actually, we are collecting metadata. So we are collecting information that are associated to images. Of course, we cannot think to develop a central repository of preclinical images. But the advantage of having this kind of repository is that you can look, or you can have, let's say, a search engine that allow you, or a database that allow you to find preclinical image datasets. The moment we have started, we have 19 datasets. 3 more will be upgraded, will be uploaded in the next weeks. It's a quite well-curated dataset repository because we have almost 200 metadata that describe all the different information associated to the preclinical image dataset, and we are also providing information in a way in which you can have access to the data, and potentially also by providing link to the image dataset. And this is just an example. Actually, this is the older version, since we are also changing the interface, the web interface. But you can see here that we are collecting per each image dataset several types of information that are divided in sections. And you can see here highlighted also the use of the ontologies that allow you, therefore, to provide this kind of link between the name that you are using and the specific term within each of the ontologies that you are using. And another advantage is that when you go into the description of the dataset, then you can also have a link to the dataset. And if you provide a link that it could be any kind of repository potentially, in this case we just show you an example, a link to our XNAT repository, then you can go directly into the dataset, and then also thanks to the viewer within the XNAT platform, then you can directly look to the images. So this is just a way to link the information of the images then down to the actual images. So let me thank the people, in particular the partners of the foundingGIDE projects that are also here, some of them, and then the people, my group, that are working on developing this kind of metadata model and repository. And thank you for your kind attention.